Before we get started in combining and composite functions, I think we need to review finding the domain. Now, for the domain, we're going to say that if our function does not model real-world data, then we're going to take its domain to be the largest set of real numbers for which the value f of x is also a real number. Okay? Now, I want to stress that the reason we say if it doesn't model real data, if this is something we're doing for a furniture factory and they're making couches and chairs, I don't want real numbers because I can't make a negative number of chairs. I can't make a fractional number of chairs. In that case, I want to restrict it even further to just whole numbers. Okay? But in the general sense, which is where we operate in algebra, in the general sense, I want the largest set of real numbers that keep my value a real number. Now, what does that mean? That means that I'm going to have to exclude any numbers that might actually cause me to divide by 0 because that's not a real number, it's undefined. I'm going to have to exclude anything that will result in me trying to take an even root of a negative number, a square root of a negative number, a fourth root of a negative number, etc. I'm going to have to exclude any of those values. So let's take a look at what that means through a practical example. Find the domain of function h. Function h is a polynomial function. There is no way for me to end up dividing by 0. There is no way that I'm going to be taking a square root or a fourth root of any number up there. None of that's up there. No matter what I do here, I am going to end up with a real number. So my domain here is the set of all real numbers, which is the interval from negative infinity to positive infinity. However, if we look at function g here, okay, I don't have any issue with the numerator. I don't have a problem with the numerator being 0 because 0 divided by anything is just 0. But I have an issue with the denominator because it looks like there may be a possibility of me dividing by 0. Now, how do I know what that would be? I take my denominator and I set it equal to 0 to find out when that's going to happen. Now I'm going to solve by chunking because I think it's faster. Since they said minus 49, I'm going to say plus 49. Since they said squared, I'm going to say, well, let's take the positive and negative square root. And the square root of 49 is 7. So I have two numbers that I have to exclude from my domain, positive 7 and negative 7. Either one of them, if I substitute, I get 5 times 7 or 5 times negative 7 in the numerator, and that's fine. But in the denominator, I get that number squared, which in both cases will be positive 49 minus 49, which gives me a 0, and thou shalt not divide by 0. So my domain says I can start at negative infinity, count all the way up to negative 7. But I've got to jump over negative 7. Then I can keep going out to positive 7. But then I have to jump over 7. And I can keep going forever. So this is how I exclude those two numbers from my domain. And one more example to show you the types. I have a function here, f, that has a radical in it. And it has an even index, the understood square. Okay? So I don't want what's under the radical to be negative. So I just say set that radicand greater than or equal to 0. It will be okay. The square root of 0 is 0. So getting a 0 is okay. I just can't let it be negative. So since they said minus 27, I say plus 27 on both sides. Since they said times 9, I say divided by 9. I get that x has got to be greater than or equal to 3. Now, I know this is where you left it when you looked at it in Algebra 1, but now we're going to write our domains in interval notation. So I'm going to not do that. I'm going to say, since it's or equal to, I want the close sign, 3 to infinity. This says start at 3, including 3, that's the or equal to, and keep going right forever. So those are what we're going to do for exclusions to domains. And as we go through with combining and composite functions, we're going to have to make restrictions on our domain based on these things.